Let's solve this following differential equation. We begin by rewriting the equation as 2xy dx equals to negative x squared plus 2y squared dy, or dx over dy equals to negative x squared plus 2y squared divided by 2xy. The term on the right hand side, if we consider it as the function f of x comma y, here we are going to make a substitution. Substitute the value of x with lambda times x and y with lambda times y. In doing so, if we obtain the function back, then we say that our function f of x comma y is a homogeneous function. Because the function f is homogeneous, so this is a homogeneous differential equation. Now, in order to solve this differential equation, we cannot apply the method of variable separation. The reason behind this is this cannot be expressed as the product of two functions, g and h, where g is purely a function of x and h is purely a function of y. But what we can do here, we can do a little bit of substitution, which will convert this homogeneous differential equation into a variable separable form. The substitution will be x divided by y equals to v, or simply put, x equals to v times y, where v is also a variable. Now, differentiating both sides with respect to y gives us dx over dy equals to v plus y times dv over dy. What we have done, we have applied the product rule to differentiate vy with respect to y. Now we'll use this new substitution and the expression for dx over dy to rewrite our differential equation. So our differential equation then becomes v plus y times derivative of v with respect to y, that will be equals to negative. So here in the numerator we have x squared, so instead of x squared we will rewrite it as v squared times y squared plus 2y squared divided by, we have 2xy, x will be replaced with vy, so we get vy squared. We already have a y here. Immediately we can factor out y squared from both the numerator and the denominator, so this will then become, now we'll take the v from the left hand side to the right hand side, so we can subtract v from both sides, and this will give us y dv over dy equals to, let's combine these two terms, so this will become 2v, we have v squared plus 2 plus 2v squared, so that's going to give us y times dv over dy equals to negative of, so 2v squared plus v squared, so this will be 3v squared plus 2 divided by 2v. Separating the differentials, we will have 2v divided by 3v squared plus 2 times dv equals to negative dy over y. So this is now in the variable separable form. We can integrate both sides. Integration, to integrate the integral on the left hand side, what we'll do, we will multiply with factor 3 and then we divide with 3. The reason behind this, if we make use of the method of substitution and let 3v squared plus 2 equals to some variable and differentiate both sides with respect to v, we will obtain, now this is not x, this is a multiplication, so we will get 3 times 2v, which is 6v dv. You can perform the calculation. This is a very simple integral. I'll go ahead and write the result. So this will be 1/3 of natural log of 3v squared plus 2 equals to integration of 1 over y with respect to y, that will be negative log of y plus the constant of integration c. Since everything is in terms of logarithm, so we'll take natural log of c. Right. Now we'll use the property of logarithm. So this 1 over 3, this can be written as the power of 3v squared plus 2. That means we can rewrite it as 3v squared plus 2 whole raised to the power of 1/3. and this will be equals to, combining these two terms, will be natural log of c over y. We can get rid of the logarithm from both sides. It will leave us with 3v squared plus 2 whole raised to the power of 1/3 will be equals to c over y. Then what we'll do, we'll take the cube on both sides to get rid of the cubic radical on the left hand side. So we'll have 3v squared plus 2, and this will be equals to c cubed divided by y cubed. Now what's v squared? So we assume that the v is equals to x over y. So let's substitute it here. So v squared will give us x squared over y squared plus 2 equals to c cubed over y cubed, or simply y. We'll consider the positive values. Now multiplying throughout this equation with y cubed, so that's going to give us 3x squared y plus 2y cubed equals to c cubed. And finally, if we take y as the common factor, so we have y multiplied to 3x squared plus 2y squared equals to some constant a, where we are assuming that the value of this constant a is equivalent to c cubed. So this is going to be the required solution to our given differential equation.